Hi, this video is to help you understand how to perform the experiment determination of the temperature dependence of the solubility product of calcium sulfate and its standard enthalpy and entropy changes. It's not meant as a substitute for the procedure. It's just meant that if you watch this video, as you look through the steps in the procedure, you'll understand a little better what they're asking you to do. So this is the equipment that I'm going to use to perform the part of the experiment I'm going to demonstrate. In this experiment, you're going to do 3 trials where the procedure is performed identically. You're going to do 1 trial with ice water, 1 trial with room temperature water, and 1 trial with hot water. So I'm just going to demonstrate one of those trials. I'll do the hot water trial, and you'll follow the same exact steps for all 3 temperatures. Now, the first thing we have to do is a few weighings in advance. So you're going to do this 3 times with 3 filters, but take your filter paper, or 3 filter papers, and you want to fold them up so that when you lay them on the scale, they don't flop around and go off the pan of the scale. And turn the scale on and wait till it reads 0 and weigh your filter. And now you want to notate that mass on the filter, along with a notation of which trial you're going to do. I'm going to do the hot water trial, so I'm going to write hot on that. Okay, then you can put that off on the side. The next thing we have to do is we have to weigh out about 0.5 grams of calcium sulfate, and we want to weigh it directly into one of these screw lid containers. So put the screw lid container on the scale and tear the scale so that it reads 0 with the screw lid container on it, and then take out your calcium sulfate solid that we have in the kit. Okay. And 0.5 grams is a very small amount. A small fraction of a spoonful. Okay, there we go. Now, both of those masses we ought to get recorded in the data table. So we had to weigh out about 0.50 grams, and it happened that we did weigh out 0.50 grams actually. And the mass of the filter is 1.78 grams. Next thing we do is we need to obtain a bath of water. So I'm doing the hot trial, so I'm going to go get some hot water. And by hot water, I mean the hottest water I can get from the tap without using any external heating devices. Okay, so I'm back with my hot tap water now. And what I want to do is I want to transfer 100 milliliters of the hot tap water into here. And I want that to be measured as carefully as I can. There are markings on this container. They're a little hard to read, but if you want to take a marker and locate the marking, there's the 100 ml marking, and make it a little clearer to read. That's a good idea, I think. And then add the hot water until you're close to that mark. And then once you're close, use a dropper to adjust to as precisely as you can right up to the 100 ml mark. Okay. Want to put the cap on this container. Make sure you close it securely. We're going to shake it. And you want to give it a shake. And we want to keep this at about the same temperature so that it doesn't cool down too much. So we're going to use the rest of this hot water as a hot water bath. So take the container after you shake it up a little bit and immerse it in this bath. Okay. And you can set a time. We want to let it sit for at least 2 minutes. Longer is okay. A little bit longer is okay. We don't want the water to cool down too much, but around 2 minutes or a little bit more. And we're going to measure the temperature over in the funnel, but we'd like to get the thermometer up to close to the temperature it's going to be at. So you can put your thermometer into this hot water bath while that 2 minutes goes by. Okay. So while that 2 minutes is passing, you want to set up a filtration apparatus using that pre-weighed filter. So filtration apparatus in this course is always that we use a coffee cup to collect solution if we're interested in that. And we put these disposable funnels on top of the cup and use a coffee filter. And this is the pre-weighed coffee filter that I have for the hot trial. Now, after 2 minutes has passed, I'm going to take the thermometer from here, and I'm going to transfer it over here. Okay? And I'm going to take the solution out, and I'm going to give it a shake and tape. Some of the solid isn't dissolved. It's on the bottom. I want to transfer, if I can, all of it. And I'm going to pour it over into the funnel here. Okay. In order to make sure all of it gets transferred, I'm going to take one full dropper full, that's about 3 ml, squirt it in here, swirl it around, and wash it into the funnel. As the solution drains, when the solution is about halfway through, you want to note the temperature. I saw that it was 43.5 a moment ago, right before the solution finished draining. That's what I'm going to record as the temperature for this trial. So after the solution has drained through, you want to take this filter, and this filter needs to be stored somewhere where it can safely dry. As we've done in other experiments, we need to dry it out without losing any of the solid that's in there. So you could hang it up. You could use one of the binder clips. We gave you 3 of them in your kit. You could hang this up like on a clothesline, or if necessary, you could just leave it laying out in your work area. And if you do that every day or so, turn it over. If you could also lay it in a place that's warm, like if you can hang it near a radiator or something like that, that would be good. And after a week, we're going to reweigh this filter. So now a week has passed. I've had this on my window near the radiator. So now I'm going to weigh it to find out how much calcium sulfate is trapped in the filter. Okay. And that would be the mass here, 1.98 grams. So the mass of calcium sulfate in the filter is just the difference between these two. Looks like 0.20. And that means since there was 0.50 grams I started off with, if 0.2 of it ended up in the filter, the mass that ended up dissolving would be the difference between those two, 0.30. So next we need to calculate the number of moles of the calcium sulfate. So I added up the molar mass of it for you there, and 0.30 grams dissolved in my sample trial. So that would be 2.2 times 10 to the minus 3 moles. And next we need to calculate the molarity of the calcium sulfate. Now remember, we prepared 100 milliliters of solution, but then we used 3 milliliters, 1 dropper full approximately. We estimate that to be 3 milliliters to wash the container. So the total volume was 103 milliliters, or 0.103 liters. So that would be the molarity. Okay. The temperature we observed was 43.5 degrees Celsius when the solution was filtering in the funnel. Okay. And that calculates to 316.7. And to calculate the KSP, we would use an ICE table. In this trial, we started off with the water by itself. So initially, the amounts here were zeros. And we usually represent the changes as x's. These would be plus x's. But in this case, we had a way to directly measure the equilibrium amounts. We know the amount of the solid calcium sulfate that dissolved. We know its formal molarity. And it has a balancing number of 1, just like each one of these ions. So what we would refer to as the molarity of calcium sulfate is actually the molarity of these dissolved ions. Okay. And we had that as 0.0214. Only 2 of those digits were significant, but 0.0214. We don't want to round yet. The equilibrium expression for this reaction is the same form of all KSPs. The molarities of both of these dissolved substances. At equilibrium. So we can just plug in. It will be 0.0214 squared. Okay, so I square that, that's what I get. We only have 2 significant figures though, so we should say 4.6 times 10 to the minus 4 would be our value for the KSP. One little follow-up note, in the experimental procedure for this experiment, it tells you to, when you're measuring the temperature here, to measure two temperatures. The temperature when you first pour the solution, and then when the solution is almost fully drained, and it says when the temperature probe is just fully immersed. When I was performing the procedure on camera, I found that was impractical. I think the best we could do is record a single temperature, which the temperature that we observe while the solution is draining. So that's the way I perform the experiment, and that is how I suggest that you perform it yourself.